Hello everyone! Today my teammates and I will be discussing our trip to Magome, Tanzania in January of 2020. We participated in the Design for Life Water in Tanzania Global Seminar at the University of Minnesota Twin Cities. As a bit of background about the course, we spent fall of 2019 meeting as a group and preparing for travel. We departed Minneapolis early January and spent almost 3 weeks on the ground in Iringa region of Tanzania. We spent most of our time studying Tanzania design guidelines, reviewing fluid dynamics, visiting villages with previously implemented designs, and making sure we were ready to collect data for our own design. Near the midpoint of our trip, we split into small groups and each traveled to our own village, where the goal was to design a water distribution system based on our community's needs. After a quick stop in Ruaha National Park, we headed home and spent spring semester designing our system with the data we collected. But before we discuss the details of the project, my team and I will introduce ourselves briefly. My name is Jordan, and I was the mechanical engineer on this project.
Hi everyone, I'm Sam, and I'm a chemical engineer.
Hi everyone, my name is Britta, and I was the lone industrial and systems engineering student to travel with the team to Tanzania.
Hey everybody, my name is Peter. I graduated this spring, making me a senior when I went to Tanzania with the group. I graduated with a degree in civil engineering.
Throughout the course of this presentation, we will discuss the background of the village of Magome, as well as the ability and level of preparation of the village to receive and maintain a water distribution system. We will then outline the current water situation of the village and move into our proposed design, as well as the associated costs. And finally, we will end with some community highlights from the village. Our journey to Magome village started with a 3-hour car ride on an extremely bumpy and muddy road. During the wet season, the road conditions can be difficult, so we were all excited when we arrived at the village without having to get out and push the vehicle. When we arrived, we were greeted by a breathtaking view overlooking the village of Magome and the lush landscape that surrounded it. Magome is located in a mountainous area at about 6,000 feet in elevation, with the community built on the ridgeline. The school is the point of highest elevation and is located at the top of the hill in the photo. Another thing to note about the photo is that there are power lines. However, we learned that no power is currently supplied to these lines, but it is expected by 2021. After we arrived, we got a tour of the village. We learned that Magome occupies a piece of land about 4.5 kilometers by 2.5 kilometers, or 2.8 miles by 1.6 miles in dimensions. It contains a population of about 1,147 people divided between 4 sub-villages. We have Mandege in the south, and then moving north, we have Mtule, Alala, and Magome in the east. Salem is a nearby community that is not considered a part of the village directly. If you look in the center of the map, you will see Alala, which is considered to be the center of the community. It contains the primary school, the dispensary, the market, and various churches. It has 4 contaminated sources located nearby, and as I mentioned before, the people live along the ridge of the mountains, while the water collects in the valleys. This makes water collection a very time-consuming and laborious task for the people of Magome. And since the school is at the highest point, collecting water is the most difficult for these young children. You'll also notice that the village's 3 clean sources are located farther away from the village center and are less frequently trafficked. The farthest source from the village, Mohanga Spring, is about 3 kilometers away. Hiking to this source, we had a few falls due to the difficult terrain, and this is why many villagers use the closer contaminated sources, as opposed to the cleaner sources located farther away. After getting a feel for the layout of the community, we met with the water committee to learn more about the village's water situation and leadership. From this meeting, we learned that the village's water community was established in 2017 and currently consists of 8 members, 4 men and 4 women. The members were elected representatives, and there are at least 1 representative from each sub-village, which ensures a diversity of leadership. As for the village's savings, during our visit they had a little over 2 million tish, which converts to about $943 in savings. This is a great start and demonstrates the fundraising capacity of the village. Throughout our conversation, we also noticed that the members were all very united under the common goal of gaining access to clean water for the benefit of the children in the community. When we asked the Water Committee about the village's priorities, the members unanimously made them very clear. Their first priority was the primary school, in order to get water to the children. Next was the dispensary, to help the sick, and finally the market and church, which would provide clean water to the village center. For reference, 80% of Magome is Lutheran, which makes the church a community center and a general place of gathering. Our design was centered around these priorities outlined by the villagers, but before we can discuss our design, we'll share a bit more about the village's water sources.
As Jordan mentioned, we spent a lot of our time in Magome learning about the village and their priorities. In addition to that, another large chunk of our time was spent hiking to and testing different water sources. We ultimately ended up testing the water at 7 different locations throughout the village. Some were frequented by villagers because they were nearby to the village center, and others were more remote and therefore not used nearly as often. We tested the water by taking a sample and putting it onto a Petri film. The samples had to be incubated for 24 hours, so we used our body heat and took turns serving as mother hen. After 24 hours, we would check the samples and see if any coliform or E. coli had grown. Ultimately, we discovered that samples 1 through 4 were contaminated, and 5 through 7 were clean. However, I should note that locations 5, 6, and 7 are all fed by the same spring. So before we get to the clean samples, I wanted to go over the contaminated samples in more detail. On this slide, you can see the Petri film from each contaminated sample after 24 hours of incubation. The purple dots seen are E. coli colonies that grew during the incubation period. All of these samples have either high or very high E. coli contamination risk. Source 1 was one of the most contaminated sources that our mentor Ken had ever seen, and unfortunately, it is also the source used by the school and the dispensary, 2 of the most at-risk populations for contracting waterborne illness. Considering that the population of Magome was about 1,150 people, the fact that in a month anywhere from 200 to 500 people visit the dispensary indicated to us that people are getting sick from contaminated water. During our conversations with village leaders, we asked if villagers and students boiled their water before use. Their response was that boiling water is encouraged, but doesn't always happen. Before leaving, we tried to emphasize the importance of boiling water to reduce the risk of waterborne illness. As you can see on this map, each of the 4 sources I just discussed are the ones closest to the village center. Because of their proximity to people, they are also the most used. You can see that Source 1 is located between the school and the dispensary, and Source 4 is used by the Lutheran Church, which 80% of Magome's population attends.
So not only is the water that they're collecting unsafe, it also requires an extreme amount of effort to retrieve the water and bring it up to the school. As you can tell from the elevation profile shown, the path from the source to the school is very steep. It took us between 20 and 30 minutes to hike to the top, and by the end of it we were all dripping with sweat and exhausted, and that was without carrying any water. So you can only imagine how draining it must be for the kids who have to make this climb multiple times a day, but with 30 pounds of water on their head. We were told that classes are often postponed for children between the ages of 8 and 15 to collect water, and that it takes them between 30 and 45 minutes per trip, and that they make up to 3 trips a day. So if you're doing the math with me, that can be over 2 hours a day taken away from learning, and that has an obvious detrimental effect on their education. Understandably, these students who collect this water will get tired and thirsty on their way back up to the school, and will often drink straight from the bucket that they're carrying without boiling it. And to reiterate, this was the most infected source in the entire village, and not only that, it was the most infected source that our leader Ken has seen in all of his visits to Tanzania. Thankfully, there were some sources that tested free of E. coli, which is indicated by the absence of dark blue or purple colonies. You may note that there are some red colonies present on a few of these petri dishes, and that is due to the presence of coliform bacteria. However, this is not overly concerning, as coliform is present in soil and is not inherently dangerous. While these 3 sources are safer, they are seldomly used because they require 3 kilometers one way of difficult hiking just to reach. As you can see here on the map, the 3 clean sources are located outside of the village. Sources 6 and 7 are both river sources, while Source 5 is the Mohanga spring, which feeds into Source 6. We chose to base our design around Source 5, the Mohanga spring. As you can see from the video, the water flowing from the spring is crystal clear, a stark contrast to the brown water serving the dispensary and the school. As I've mentioned, this source is very rarely used because it requires 3 kilometers of hiking with an elevation gain of 100 meters. In fact, the hiking was so difficult that even a few of us wiped out on the way up to the spring. Thankfully, no one got hurt, but it just goes to show why the villagers might prefer to collect from other sources. While the drastic elevation gain proved to be difficult from a hiking perspective, it was actually very advantageous from a design standpoint. Because the Mohanga spring was at a higher elevation than the village center, it meant that a gravity-fed system was possible.
For the Phase 1 design, it will be an entirely gravity-fed system supplied from the Mohanga spring source. At the spring, there will be a large cement cistern where the water will be collected and treated. For those who are unsure what a cistern is, it is an enclosed tank where the raw water will sit until it flows into the water line. When I say it treats it, it's more of it serves to settle out all the meaningful particles that may flow out of the ground. Once the safe and fresh water leaves the tank, it will travel through almost 3,000 meters of 1.5-inch pipe to 2 10,000-liter tanks located at the village center. As seen by this elevation map on the screen, there is some significant elevation change from the Mohanga spring to the tanks. Therefore, thicker pipe is needed at the bottom of the hills to withstand this pressure from the elevation change. From this village center, there will also be 3 supply lines to feed throughout the village. These supply lines will also give water to the village's top needs. This map on the screen shows the gravity main from the cistern to the village center. The picture on the left is an example of what the cistern will most likely look like. You can see in the bottom left corner that the Mohanga spring is, and then the green dashed line is the 3-kilometer line all the way to the village center. Once the gravity main is in, the 3 supply lines with the dispensary points will be installed as shown on the map. As mentioned before, these DPs are strategically placed so that the village's top priorities can be fed with water. The supply lines on the map can be seen by the blue dashed lines. The dispensary points can be seen by the dark blue marks on the page.
As we designed the system, we wanted to ensure that it would get clean water to the village's highest priority locations. Phase 1 of our design does this by providing water to the school, the dispensary, and the village center. This phase will serve approximately 1,045 people, which includes the 332 children that attend the school. The design also reduces the labor required to collect water and will reduce the risk of waterborne illness. As you can see, pipe is the most significant direct cost in this phase of the design. This is due to the large amount and the high pressure rating needed. Labor costs are another significant expense, but labor will be the village's in-kind contribution to the project. Upfront costs to build the system are not cheap, but maintenance expenses will be very small given that the system will be gravity-fed, so no external input, like power, will be needed. The total cost to donors for Phase 1 of the project will be $20,600, which comes out to a cost per person served of only $19.71.
Once Phase 1 is installed, a Phase 2 for the village can be implemented. This system will pump water up to 52 meters from the storage tanks to the primary school. This pump will run off the grid power, which is soon to be installed in the village. There will be a 10,000-liter tank at the school where this water will be stored. There will also be 2 short supply lines from this tank, one to the Salem sub-village and the other to the Magome sub-village. So looking back at our village map, you can see we have the Phase 1 design currently on the screen. Now, once you add Phase 2, one can see that there is an orange line running from the 2 10,000-liter storage tanks to the primary school. At the primary school, then there is 2 more orange lines, one running to the town of Salem and the other to the Magome sub-village. There will also be DPs at both of the end of these lines, as shown by the dark orange marks. So the main purpose and accomplishment for Phase 2 is to primarily deliver on-site water to the school, which Phase 1 cannot directly do because of the elevation change. In addition, the final village of Magome will be given water, totaling almost 600 people being served from Phase 2. When looking at the approximate cost breakdown, one can see that this cost is relatively cheap when looking at price per person breakdown. In addition, the children at the school will have on-site fresh water at all times, which was the village's top priority when we met with them.
One thing that stood out to me while we were in Magome was the impact that having a water distribution system would have for specifically the women and children of the village. Often we'd see the women walking past us on their way up a steep hill with a baby strapped on their back and a full bucket of water on their head. I was amazed by the strength of the women and children because not only are those water buckets heavy, but the hikes they take to get water are not easy. When students no longer have to spend hours a week fetching water during school, they will be able to learn more and progress further in their education. With a water distribution system, both the women and children will not have to endure so much physical stress and will have more time to take up other hobbies and generate more potential income for their families. The women and children already do a lot of strenuous work in Magome, but a water distribution system would allow them to put their hard work towards other things.
My community highlight was definitely seeing just the general kindness and unselfishness that the people in our village just showed to us throughout our stay. In particular, one of the people who hung out with us the majority of our trip, Nikita. Nikita's story was he used to live somewhere else and moved back to the town when he heard that the school didn't have a teacher. He knew kindergarten well and decided to come back and teach kindergarten for free and volunteer because he wanted to. I thought that was really cool. He dropped everything and came back to his village where he was from to just kind of help out when they needed him, and kind of showed me that if he could do that, I should be able to, give back and help them get water like this.
For me, the best part of being in the village was the kids. It was just so fun to throw a football back and forth with them and see how excited they'd get whenever a ball came their way. A couple times they would even wait outside in the rain and hope that we would come back outside to throw the ball with them. By far the most fun thing to do with them was to show them the different Snapchat filters. Here's their reaction when I showed them the dog face filter. They laughed and screamed for probably an hour, and it was just so funny to see. Seeing genuine joy on their faces from things that we often take for granted was just really cool. And that was true for the village as a whole. All the people who welcomed us into their village were some of the happiest, most kind people I've ever met, despite their unfortunate circumstances. It was really just a powerful lesson on how happiness does not come from circumstance or from material possessions, but instead comes from within and from the people you surround yourself with.
Throughout our time in Magome, one thing that was difficult for us as a team was not being able to promise the people of Magome that the water distribution system would be implemented. It is difficult for us to imagine not being able to follow through with our design after seeing the condition of their current water sources. Our hope is that one day we will be able to return to Magome with the proper funding and be able to implement the distribution system to give them the guarantee of clean water. If you're interested in donating to the Magome Project, please visit designforlifeinternational.com, where you can navigate to the Magome Project and make a financial contribution. Thank you for considering helping us get one step closer to delivering sustainable, clean water to the people of Magome. This website will also allow you to learn more about other student-designed water projects in the Iringa region of Tanzania, as well as discover more ways to get involved. And finally, we would like to thank Professor Paul Strzałkowski and Professor Matt Anderson for leading this course in applied fluid dynamics and for providing us with the knowledge and resources that made this project possible. We would also like to thank Dr. Ken Smith, our industry representative from 3M, for his expertise and guidance as we navigated Magome Village and tackled our design. The following slides provide additional information regarding various aspects of the project, including cost, topology, population, water supply and demand, and much more. Feel free to pause the video at any point to read more information on each of these topics.